In this lesson, we're going to be taking a look at solving radical equations. So up here right now, you can see a cube root equation, and that's what we're going to be solving here. So the basic idea behind solving any kind of these radical equations is to start by trying to get the radical part by itself first. So that means that we want to isolate this cube root of x plus 2 before we can do anything else. So notice that means we got to get rid of the 5 and the plus 9. And so, of course, in order to do that, we want to start by getting rid of the addition subtraction. So I subtract 9 from both sides. And now I can get rid of the 5. So we divide both sides by 5 now. So notice we've gotten the cube root by itself. We now need to get rid of the cube root. That means undoing it. The opposite of a cube root is cubing. And so what we're going to do then is we are going to cube both sides in order to make that cube root go away. Now when we do that on the left-hand side, cubing the cube root simply means that that cube root symbol goes away because we canceled it. On the right side, I actually have to do the negative 4 cubed. And notice that if I do a negative number cubed, I do get another negative number. Keep track of those signs when you're dealing with these various exponents. And so then, now that I have x plus 2 equals negative 64, I simply subtract 2 from both sides, and I have my answer of x equals negative 66. And that's the basic idea behind solving these radical equations. Now let's take a look at a couple more here. Both of these are square roots. Okay, well, once again, I need to start by getting the radical part by itself first. So for this first one then, that means I'm going to add 4 to both sides. And then I have the square root of x equals 9. Well, when it was a cube root, I cubed both sides. When it's a square root, remember that is the same as a second root. There's an invisible 2 sitting in our radical there because it's the second root. Square root, second root, same thing. And so in order to undo the square root, we're going to square both sides of our equation. And so when we square both sides, squaring a square root makes that radical go away. So we're just left with x on the left side, and then 9 squared is 81. And that one's done. We know that x equals 81. All right, now we go on to the next one. And again, we want to start by getting the radical by itself. So notice that means getting rid of the 3 on both sides. So I'm going to subtract that. And then I can get rid of the radical. And notice it's a square root. So once again, that means I'm going to want to square both sides of my equation. When we do that, we have x plus 5 equals 16. Notice since it's x plus 5, I still have to get rid of the plus 5. So we subtract the 5 from both sides. And we have x equals 11. Okay, no problem, right? Well, let's work through these last couple because you're going to notice something comes up along the way here. All right, so for our first one, again, I want to get the radical by itself first. So I'm going to go ahead and subtract 1 from both sides. And now I have the square root of 3x equals 6. Notice the 3 is on the inside of the radical, so I can't do anything with it yet. I instead now have to get rid of the square root because that's the outermost part of the equation on that side. So I'm going to square both sides of my equation. Notice then I have 3x equals 36. It's a 3 on the outside here because it was a 3 on the inside of the radical. Remember that squaring it only got rid of the radical symbol. It doesn't mean we change what's inside in any way. And so now that I have 3x equals 36, I can go ahead and divide both sides by 3, and we have x equals 12. And we're done. All right, then on the next one, again, I want to get the radical by itself. Hey, I already got that, so I can go ahead and start by squaring both sides of the equation. Easy, right? So I square both sides, and I subtract the 2 from both sides, and I have x equals 79. There's just one problem with this answer. It doesn't work. If you take that x equals 79 and plug it back into the original equation here, you notice we would end up getting the square root of 81, which is a positive 9. And positive 9 does not equal negative 9. This is the wrinkle that we are going to have to be paying attention to now. Because what ended up causing this to look like it was a solution when really it wasn't, actually was on the very first step we took, where we squared negative 9. Because negative 9 squared is a positive 81, yes. But the square root of 81 is not negative 9. And so what we ended up with here was what's called an extraneous solution. It's a solution that looks like it's a solution but really isn't. Now, this can happen anytime we try to solve a square root equation. Because a square root will always be positive, if you ever find yourself with a square root set equal to a negative number, like we did up here, at that moment, when the square root is by itself and it's set equal to a negative, then you can say that there is no solution. Now, the square root does have to be by itself before you can conclude that, because perhaps moving stuff outside the square root over to the other side will make that other side positive. But once you hit that point, you could actually go straight to concluding no solution, or the solution does not exist. Now, one additional little side note with this is the square root, because we're most familiar with that, but actually it would be true for any even root. So a fourth root could also not be negative, a sixth root could not be negative, an eighth root could not be negative, and so on. So anytime it's an even root, if you end up with that radical set equal to a negative number, there is actually going to be no solution to it. And again, we call those answers that look like they're answers but aren't really extraneous solutions. And that's going to be something we deal with a little bit more as time goes on in this class as well.